All right. So yesterday we started work on the distance formula, finding the area and the perimeter of particular polygons. We're going to enhance that a little bit today with triangles and the Pythagorean theorem. So coordinate geometry is one of the most important and I think exciting ideas of mathematics. It provides a connection between algebra and geometry through graphs, lines, and curves. But there are different methods to finding the distance of lines. Okay, there are different methods. So let's start off by looking at this first one here, this first problem, method number one. Okay. Method number one says, when the lines are vertical or horizontal, we can find the length by counting. Okay? So when the lines are vertical, this is a vertical line here, or horizontal, we can find the length by counting. So do me a favor, count those spaces and write in the two answers here. And if you counted the horizontal AB, you should have gotten, because this does count by ones, 1, 2, 3, 4, 5, 6, 7. If you counted the vertical CD, you should have gotten 1, 2, and 3. So now the question is, will that kind of a method work for this line? I can't count the squares for that, can I? So if I can't count the squares, what did we do yesterday to find that distance?
Y minus, well,
What is that?
X,
Oh, thank you, James, for raising your hand.
We write the points down, right, and then we do the y ones.
I couldn't hear you. He was still going off over here. Go ahead.
We write down like where the points are, and we do the y one.
Okay, what's that called?
I know what it's called, but I just can't think of it.
I already used the terminology once. Do you have your hand up? No? Okay. Yes, Jacob, what's that called?
you do the Pythagorean theorem.
Okay, what did we do yesterday?
It's,
You have no idea what you did yesterday?
it's for distance.
For homework? Yeah, what's it called?
Distance.
It's called the distance formula. Yeah. It's just the distance formula. Yeah. So can it work for, will counting work for this particular method? No. What did we use yesterday? We used the distance formula. And that was d equals, right, the square root of the x value from point 2 minus the x value from point 1 plus the y value from point 2 minus the y value from point 1. Okay? So we use the distance formula. Now, when working with diagonals, we can also use a different method. And Jacob alluded to that just a moment ago. And that would be the Pythagorean theorem. Pythagorean theorem.
Yeah, it's
Pythagorean. Yes?
Aren't the two parentheses on a distance formula supposed to be squared?
Yes, they are. Thank you. I missed that, didn't I?
Yep.
Yes, thank you, Anthony. Yeah, those were supposed to be squared, sorry. All right, so when working with diagonals, we can use the Pythagorean theorem that can be used to determine the length. Okay? It can be used to determine the length. So if we're trying to find the length of segment EF, we can do that a little differently now. So if I'm trying to find EF, I can create imaginary lines. Okay? I can create imaginary lines. And if I create those imaginary lines, the length of this side is going to be 3. And the length of this side is going to be 4. Okay, 3, 4. So it asks us what is the length of EF. So if we're going to use the Pythagorean theorem is the hypotenuse squared is equal to one of the legs squared plus the other leg squared. And we're talking about the lengths, right? So the length of the hypotenuse is equal to the length of the leg squared plus the length of the other leg squared. Well, we know what the legs are, right? This is the hypotenuse because it's always opposite this right angle. That's where the hypotenuse is on a triangle, on a right triangle. It's always opposite this right angle. And by the way, hypotenuse is only on right angles, right? Or right triangles. So if we're going to solve for the hypotenuse, the side we're looking for, we know that one of the legs is 3, the other legs is 4, and if we take 3 and square it, we have 9. If we take 4 and square it, we have 16. So c squared is equal to 25. Right? C squared is equal to 25. But we don't want to know what c squared is. We want to know what c is. We want to know what the length of EF is. Right? So if this is EF squared,
So we're only equal to 5.
to find EF, I have to take its square root. Now if I take the square root of this side, I have to take the square root of that side. So C is going to be equal to the square root of 25, which is just 5. And that would be the length of EF. So will this particular method always work?
No.
The answer is yes.
It's the same paper.
The answer is yes. You can use this instead of the distance formula. Why can you use this instead of the distance formula?
I believe that it's so much of an easier way to do it.
Might be a little easier way for some of you. Some of you might like the other way better. But because I can draw those imaginary lines and create a right triangle, I can find that length each and every time. Let's turn the paper over. So, when working with diagonals, we can also use the distance formula. We wrote the distance formula down on the front side of this paper. The advantage of using the distance formula is you don't need a picture, just endpoints of a segment. So you don't need a picture to do that. It doesn't matter which endpoint you start with as long as whatever x coordinate you use first, that you use the y coordinate for that particular point first as well. What is the length of EF using the distance formula? So now it's asking us to find that same length using the distance formula. So find the value of this point, or location of this point I should say. Find the location of this point and use the distance formula. So this first point here would be 1, -1, right? So E is 1, -1, and F would be what? 4, -1, 2, 3, 4, 5. So 4, -5. So take a moment with your partner or with a partner next to you and find the distance between those 2 points using the distance formula.
Of course I do.
Do
All right, so when you found the length of this using the distance formula, you could have done it one of two ways. You could have had 4 minus 1, parentheses squared, plus negative 5 minus a negative 1, in parentheses squared. Or you could have had 1 minus 4, parentheses squared, plus negative 1 minus a negative 5, in parentheses squared. So you could have set it up either way. In either way, you're going to get the square root of 25. And so the answer for the length of EF would be 5. All right. We have 1, 2, 3, 4 problems here. It is a short day because we do have cars today, so we only have about 10 more minutes.
Thank God.
Thank God.
What I'm going to do is I'm going to hand out to you a piece of graph paper so that, I'll wait. I'm going to hand out to you a piece of graph paper so that you can complete these items on a separate piece of paper. The first one just says, find the length of the hypotenuse in a right triangle given the lengths, given the lengths are 8 feet and 12 feet. You may or may not want to draw a picture of that. Second one says, what is the length of a line with endpoints of 3, 5 and negative 2, 1? So you might have that one as well. The second one says the length of a horizontal segment has endpoints of 2, 1 is 8 units long. What are the possible coordinates of the other endpoints, and explain your reasoning? Okay. So remember, it's a horizontal line. Horizontal line. Okay. Tells you where it starts. Tells you how many units long it is. Be with you just a second. The last one says the length of a segment is 10 units. One endpoint is at negative 1, 0. And the midpoint is at 2, 4. What are the coordinates of the other endpoint, and explain your reasoning. Okay. Maybe too many, I've lost count. Okay, so this is going to be your homework for today. These 4 problems, and then tomorrow we should have enough information so that we can complete an assignment without being instructed. You should know how to use the distance formula. Tomorrow when you get into class, you should know how to use the Pythagorean theorem by using or answering these questions up here, and then we will go from there. Okay. Thank you, Alex. Yes, ma'am.